By now, you guys should have figured out that the two main categories of cells I was referring to earlier were prokaryotic or eukaryotic cells. In other words, sometimes called prokaryotes or eukaryotes. So at this point in the case study, we need to do a little bit of brainstorming, shaking off the mental dust that has accumulated since your freshman 8th grade year when you guys learned about the cell parts and the different types of cells. So again, in this section right here, what do you guys already know about prokaryotes and eukaryotes? And I guarantee you, within your groups, you guys can come up with some good information. Things to consider. Do you know anything about their complexity? Are they simple, complex? The size of them, are they big, small? They're cells that they're like little bitty sacks of machinery with proteins and things going on. So do you know anything about their parts and what the parts do and things like that? So again, those are the kind of things I want to see if you guys can identify. What do you already know? What's rattling around collectively in that brain of yours that you can pull out from your memory? Then, of course, if you got a lot of stuff over here, you may not have as many things on this what do you need to know side. But however, if you're kind of skimpy on this side, then yeah, you may need to bone up on the different parts of a cell and what they do and things like that. And this section down here is just a place for you guys to record information. Like I said, this is not in your copy. I typed this in just so you could have it there to read as I'm talking. It's a space to record notes and information during your research about the characteristics of both prokaryotic and eukaryotic cells. So again, because your assignment I'm going to give you, you're going to have to know the parts of the cell in order to complete the assignment. And I'll explain the assignment here pretty quickly. So again, this first part, just do it quickly in your groups. Just jot down, discuss, brainstorm. What do you guys remember about the differences between a prokaryotic and eukaryotic cell? What are some questions you guys still have about them that you may need to look up and research? And then down here is where you guys can kind of compare and contrast using the resources on my website. What the structure of a prokaryotic versus eukaryotic cell are. But I'm going to save you a little bit of time and show you these diagrams here. Prokaryotic versus eukaryotic cell. These are just general, non-specific diagrams of what a typical prokaryotic cell might look like, and a model of a eukaryotic animal cell might look like. This may jog your memory. We've got the prokaryotes over here, eukaryotic cell over here. And as you're looking at some of these terms and these parts, do you remember what they are? Do you remember what they do? What their purpose is? If not, you're going to need to bone up on that stuff, because if you don't understand this basic general function of cells, you're going to have a hard time with the more complex things later on. All right. So again, that's what you guys are going to be doing on this part of the case study. Just boning up, finding out where you're at as far as your knowledge on the differences between prokaryotic and eukaryotic cells. Then you guys are going to move on to this extension and application. It says one of the suspected pathogens was found in Ellie's blood samples. Before we can correctly identify the unknown pathogen in the blood sample, what do we need to know about human blood? Think about that. We're trying to identify something that doesn't belong. In order to find something that doesn't belong, what do we need to know about blood in general? All right. Most of you guys will probably figure out we need to know what the normal blood components are. What does a normal blood smear look like? Because that's what's going to happen. Someone who's sick, they're going to take a blood sample. They're going to do what's called a blood smear, and a pathologist or a hematologist or a phlebotomist, depending on who's available at the time, is going to be looking at that blood smear under a microscope and looking for any abnormalities, things that don't belong. But here's the kicker: you guys are neither a pathologist, a phlebotomist, or a hematologist. So you're going to need to be able to identify what belongs and what doesn't. So we need to start with identifying what's supposed to be there. What is the norm? All right. So before I just cut you loose and talk to you about your assignment, this is what you guys are going to. I want you guys to take a look at. Blood can be broken up into one of two categories: the plasma and the cellular components. Over here to the left in this diagram kind of shows you what the blood would look like if it was stuck into a centrifuge. A centrifuge is a little whirly thing that you stick it in there and it slams all the cellular components towards the end of the test tube using centripetal force, and all the watery stuff floats at the top. Oh, by the way, whenever you're in college and you're poor and you have no money, go donate plasma. I hear they're giving $50 per donation nowadays, so that's pretty good deal. It used to only be $20 back when I was in college. So inflation, I guess, is good for something. But again, back to blood components. Plasma, 55% of your total blood volume is made up of this watery stuff. It's just a mixture of water, 91%, your blood proteins like fibrinogen, albumin, your globulins, which make up about 7%, and the remaining 2% is a mixture of your hormones like insulin, glucagon, growth hormone, you name it. All right, whatever hormones that's found in your blood at that moment in time when they take that sample, electrolytes, and then that just means ions: magnesium, sodium, potassium, calcium. Uh, ions, and electrolytes are the same thing. It's just in medical terminology we call them electrolytes. And then, of course, nutrients. Whatever nutrients are floating around, we spend an entire 3 to 4 months learning about how our body breaks down, processes, moves around these molecules, all that stuff. So, yeah, we're talking amino acids, fatty acids, glycerol, sugars, things like that. So that's the remaining 2% of the plasma constituent. The other 45% is made of your cellular components, your white blood cells, which we've taken a look at some of them, the neutrophils, your lymphocytes, B cells, and T cells. We've kind of generally talked about basophils and mast phils and eosinophils and whatnot. But then you got these other components called the platelets and the red blood cells. So that's your assignment is going to be to learn what these things are and what they look like, so we can identify whether something's supposed to be there or not supposed to be there. So again, to your assignment, here's what you guys are going to do. You have 2 assignments. Number 1, you guys are going to create analogies. All right, it's one of the best ways to learn something. It's when you take something familiar and connect with something unfamiliar. Right, you're going to be required to choose 12 organelles or cell structures commonly found in eukaryotic cells. You can choose a plant or an animal cell and create a list of analogies that represent each organelle and their function. For example, the vacuole is like a blank because it blank. If you remember from freshman or 8th grade biology, a vacuole is a large storage sac for water and nutrients and enzymes and waste. So if you think to yourself, okay, what's something that I know of that is used in everyday life to store something? Could be a garage, could be a closet, could be, I've had some people say a refrigerator because it stores food and water and nutrients and things like that. So you can say the vacuole is like a refrigerator because it stores food and nutrients for the cell, just like a refrigerator stores food and nutrients that we need. So again, that's an analogy. Taking something that you're maybe slightly unfamiliar with and tying with something you are familiar with. So in order to do that, though, in order for your analogies to make sense, you've got to know what each one of these things do. If it's building something, think of something in your everyday life that builds something. If it stores something, think of things that store things. If it's packaging and delivering and or provides transport for things, just consider keeps things in and out or controls what goes in and out. Identify things in your everyday life that are familiar to you and to others that you could connect to these unfamiliar things inside the cell. Number 2, determining the norm in the blood. You got to use the links in my wiki, and I'll pull back over there and show you what it looks like, and identify and accurately illustrate all blood components and all cells. Include their average size, because that's one of the things we need to know. In the case study, it said that the pathogen is 1/10 the size of Becky's cells. Well, that's what one of the things you need to pull out. How big are these cells we're talking about, so we know what 1/10 of that cell size really is. How much of each is found in the blood? How much of the blood is red blood cells? How much of the blood are the neutrophils? How much of the blood are the monocytes, and so on and so forth? And then tell me what their functional role is. So the purpose is if you can accurately illustrate, that means draw them with detail, their physical features and structures, then you'll be able to identify what they look like in an unknown blood smear. So again, two assignments, both due on Tuesday. They're due Tuesday, the next class period. All right. Number 1, create a list of analogies using 12 organelles, 12 cell parts or structures, and then number 2, create a chart where you guys are like you can organize it, but it's got to make sense. It's got to be logical. It can be each cell type drawn with as much detail and accuracy as possible, with an explanation of what they do and their size and how much of the blood they make up, and then that'll help us move forward into the case study and start narrowing down and figuring out what the heck may be making her sick. So that's your assignment on my website. If you scroll down, all right, again, this video will be right here, the one you're watching, all right, video number 3. But if you scroll down, we've already looked at this, and here's assignment number 1. Create accurate analogies for the cellular components commonly found in prokaryotic and eukaryotic cells. And hey, I even gave you another example. For example, the Golgi apparatus is like a post office because its job is to package macromolecules for delivery throughout the cell. Just like a post office packages up mail and delivers them throughout the town. All right, I've got a link here. If you click on it, it'll take you to another page with several links on it for you guys to look through. All right, and you can use these. Of course, you can use your friend Google. This is a pretty cool video of the inner workings of a cell. I may try to find time to work that in the class sometime, but if you get a chance, check it out. It's pretty cool. But again, these resources here will help you learn the cell parts so you can work on your analogies. This video right here, links and resources, will help you with your assignment number 2. And I've got links here that will take you to help you learn about the different types of cell parts. All of them will say very similar things. Some may have a slight tweak. Find one that's appealing to you that you like to use. Same thing with the cell parts. Find one that you like, that appeals to you, that you understand, that's easy for you to grasp, and use it and go with it. All right. So again, that's your assignment. Go to these and you're creating analogies of the cell parts, and then you're illustrating and explaining the structure and function of these different cell components. All right. Both of these assignments are due next Tuesday. Don't forget, guys. Once you've gotten to this point, if you have time left in the class period, start working on your analogies and diagramming your the cell components and have them ready for next time. Don't go past this point. We'll pick up here on Tuesday. Guys, I hope you have a great weekend and stay safe and stay warm.